Hi everyone. In the previous session, we discussed about AutoCAD model and we imported the AutoCAD model directly and through IGES export. And today we will be looking to make the same model, the same geometry using Creo Parametric. So starting with Creo Parametric, the first thing we need to do is to select the working directory, because in Creo Parametric we cannot model the full cell geometry in a single part file, but instead we will need to make an assembly. So we first select the working directory, and in Creo Parametric this will be modeled to this. So this is my working directory, and as we go along, then you will see that we have multiple files that will be made, not just a single file. So we can start directly by making new geometry, and in the new geometry now we will start again. We will start towards the cathode side, that is the positive y direction. So we call it CFL, that is the first layer, and we don't want to use the default template. What we rather need is to set it in part solid. Okay, but still the part cannot do our job, because the fuel cell model, it's just 10 micron thick. So if it's 10 micron thick, will not be able to plot it. So if you try to directly draw it, as you can see, so we will draw take our top plane and use the sketch and make a rectangle. This will be 19 mm by 19 mm, and okay, and then if you try to extrude it, that will be equal to 0.01. Now it's out of range. So either we shift our units to micron and set the tolerance accordingly, or we can just directly set the tolerance and then do our job in mm's. But tolerance is the main thing that we need to change. So for that purpose, we first need to look at the units that we are working on. Now to change the units or to set the accuracy or the tolerance, we first go to file and we prepare our session. So we can go to model properties, and we can either change the units also to microns and then set it our own unit system, and the length we can set it in micron. And then set this. Okay, close. But still the accuracy is now, even we change it to microns, the absolute, it's the minimum accuracy is just 10 micron. So we need to change the accuracy. We'll go to 1 micron. Okay, so now the accuracy, we change the unit system to micron. In the unit system 1, you can see the unit system 1, if we edit it, it's in micron. Okay, and the accuracy we have changed to 1 micron. So this will now should be able to extrude our model. And now if we extrude it and we give it the thickness of only 10 micron, since we changed the units, it's better to check whether it's the correct dimension or not. So we can directly go analysis and measure length. This length is 19,000 micron, that is equal to 19 millimeter. This is also 19 millimeter, and this we extruded ourselves, this is just 10 micron. So everything checks out. So now we can save our model. save, and in the it would directly go into the working directory and CFL. Okay. Now, to make the full model, we will need to make it as an assembly. So we will start a new assembly and not default template. We'll set full cell model 2. Full cell model 2, and we should take mm's assembly design absolute. Okay, and now we should assemble our first part, that is the CFL, and use it automatic or default. Now we can create other parts from the CFL. We will go to CCCL, that is the cathode current collecting layer. That's also 10 micron thick. So we can create a new part that we call it and we'll copy from existing, and we'll copy it from the existing, that is already the CFL. Okay, so now we have another part duplicate to CCL, and as you know that this is got the same dimension, so we just need to assemble it. So we can select the layers. This surface will match with this surface. This, and in the Z direction this surface coincides with this. So now we have set all the direction, and you see it's done. So you can, it's properly assembled now. So now we have got two parts in our geometry, that is the CFL and the CCL, and we can open it. Now you see this part dimensions is the same as CFL. So if we go to analysis and measure, this 10 micron, and this length is 19,000 micron, that is 19 mm. So, and but we need to save it. Center mouse button and then save, and this will be CCCL. Okay, now we can close this window, and we're back into the assembly. So, the assembly window is actually our main window where we will be working, and above the CCL is the mesh that we need. Control D, we can always go to the initial location, and now there's the mesh that is 0.5 mm. Sorry, on the cathode side it's 0.3 mm. So we can again create part, and this will be the mesh C, cathode mesh. And copy from existing. Okay, but this time we will like to go, just leave it over here, and you see this, it's still not adjusted, so we can first open it and edit it, because the extrude, we need to modify the extrude. It's not 10 micron, it will be 300 micron. Correct. Now save it, mesh C, and close it. Now you see the mesh C directly is regenerated over here, and now we can set it. Oh, sorry, we didn't. Oh, we need to edit it. Not this one. This surface will. This surface. This. Oh. Mm. Now see, everything is set. The mesh is assembled properly, and we can see that now we have got three geometries: the CFL, CCCL, and the mesh and cathode. We can change their appearances to make a better look. So the CFL will, let's make it red, and the CCCL, let's make it, this is the current character. We just want to make to get a better visual difference, to differentiate visually. You can have it in this region and the mesh in grayish. So now you can see that we have the different appearances for the different parts. And now we'll go to the towards the anode side and create another part, and that will be the AFL, and we will be using again the CFL. Okay, and but AFL, first like to open it, modified, because the thickness is 7 micron only. So if with the thickness being, let's check if we get it right. It's 7 micron, everything checks out. So we can save this as a different part, AFL, and we can close this window. And now modify the AFL assembly file. Remember that assembly file is our main window. The top surface will coincide with the bottom surface of our geometry. The front sides matches together. And finally the surface matches with the surface. Now you see the AFL is located properly, and you can use the center mouse button, Control D, to go to the default orientation. Now you can recolor the AFL also, and AFL, because this is the anode functional layer, so we can have it some other color also. So let's make it brown. So you can see the different layers, color combinations. And the next part will be the anode support layer. So we'll make another part, anode support layer. Right now you can assemble it first and then change it also, that's not a big problem. Top layer should coincide with the bottommost layer, and this coincides with, so it's, but ASL we need to edit it. So we'll open it first and then extrude the mesh, edit the mesh, and that's 1 mm. So this will be 1000 micron thick. And now regenerate. We made some changes in the geometry, so it's better to regenerate it. And now we can see at the geometry that the anode support layer is relatively really thick compared to all the other except for the mesh, so it's relatively very thick. So and node support layer we can change it to, like, for example, green. It's too dark, so this is our node support layer. It has made the appearance of a fabric, but this is not fabrics. We can go to this wood, stone, marble, library. Or should I chrome? Fabric, leather, blue. Okay, just make it blue so that there's a better contrast with the mesh. Okay, and now we will again create another part, and that will be the mesh at anode, and we copy it from CFL. Modify the extrusion, and this will be in the node set. This is 500. Close the window, and we didn't assemble it yet, so this surface actually we need to modify it, modify the assembly. Earlier it was difficult because the surfaces were very small to capture. We have to zoom in a lot, but right now we don't need to zoom in that much. Okay, center mouse button, and now we are fixed. So we have finished with the all the layers that are coincident with each other, and now what is remaining is the manifold and the interconnect. We don't need to make separate manifold for anode side and cathode side. We'll just make one manifold and a single interconnect. That's all. So we'll have another part, and we'll copy it from again, so we'll call it manifold. Copy it from here. Don't want to assemble it right now because we'll modify it completely. So let's open it, and now for this manifold, now we want to make it actually, because that's going to be that should have channels, right? So we should add more geometry to it and exclude some geometry from it. So the first thing that we should do is let's go to the sketch plane, the top plane, and sketch it. In the top plane we will have again the inlet and outlet part. Okay, I can set the dimensions properly. So, because this is in micron, so the dimensions we can give This is this should be 1 micron, so we'll give it 1000. This should be again 1000. Okay, and now we'll make an arc. Reduce this again. I don't want to fillet it. We'll just make an arc. I think we should delete it. Okay, let's delete everything and start again. And add more reference this line, and we will add that's our first arc. Should be coincident. We first make a line. Or we can, it's better to make a circle. And it should be 2000. Now we can trim all the sections that we don't need. Yeah. We can add a center line to dimension it from this to this. This should be actually 9500, and then mirror all both the arcs to the other side. dimension, it's over constrained. Oh, sorry, we need to edit and finally add a line to it. Now it's okay. Now I can and extrude it. Okay, now this extrude we should modify it to 1 mm. That should be equal to 1000. And this extrude we will modify it again to 1000. Creo will directly add make them a single part every time. Now I want to make a plane in the center, so we'll make a plane, not the top right, this plane, make another plane. That's again 9500, and this extrusion view can mirror it in this plane. Now the last thing left is to make a pattern of sketch in it, extrude view, and from here then extrude it. And this will be 19,000. We can pattern this in not dimensions but direction. And that should be equal to 2000, and number of members 9. Now we are done with the manifold. So this is how the manifold should look like. So we have got missing the spacing for the interconnect. Okay, so you're done with this and you can save it. I can close it and you'll see that we got a beautiful manifold on above, and we need to have it in the direction of the assembly. So for this you can unselect all and get the manifold, modify the manifold. Now the surfaces that we need to select are, this surface should coincide with this surface, this surface should coincide with this surface, and obviously it should be a little bit above, and this surface should coincide with this surface. So now it's all coincident. Okay, now we need to assemble another part, another manifold, and this time we should actually rotate it first and then set it. So you see that we have assembled the same manifold in both above for the anode side and the cathode side, and now we can actually save our assembly. And the final part that we need is the interconnect. So we will again create another part, that is interconnect, and use the CFL. And this interconnect, now we can modify it. The first thing that we should do is modify the interconnect height. That is, we will take it to 1500 microns, that's 1.5 mm. And now from here we will extrude the geometries, exclude the geometries that we don't need, that are corresponding to the manifold, and that's the channels of 1 mm by 1 mm. So we'll take, for example, we'll take the top surface, right surface, sorry, front, and sketch. We'll just need to make a rectangle from the corner of 1 mm by 1 mm. We will add the equal length constraint and dimension it 1000 mm, 1000 micron. That's all. And once you extrude it, we can extrude it to the surface. That's it. And now we can pattern it again, like not dimension, direction, in this direction. Again, numbers, this time we should have, I think, 10, and yes, now see we got the interconnect geometry correctly, and we can save it. Close this part, and now we need to assemble it. For assembling it, now the bottom surface should coincide with the inside surface, or this surface will coincide, this surface will coincide with the top of the manifold. So we can have, this is easier, so we'll take this, and at the top of the manifold we'll make it. Now this surface actually coincides with the inner side of here, and this again coincides with this. Oh, sorry, we should edit it, modify it. Finally, this surface with the surface. Now the interconnect is placed properly at the on the cathode side, but now that's remaining is the anode side. So we should call in another interconnect, and first we need to rotate it. So let's rotate it, and you don't need to worry about the orientation, it will orientate itself properly. This surface is coincident with this manifold. You need to rotate like this also, and this surface is coincident with this surface, and finally this surface is coincident with this surface. Okay, now our full cell geometry is complete, so we can have a perspective view, or just turn it off. So for the interconnect, for the manifolds, we can change the manifold, so it's better to save it right now. And the appearances for the interconnect, we can have, not for the interconnect but the manifold, this is the top manifold, that's actually the cathode side, so we can have it again blue. And the bottom manifold, we can have it in red. It makes a better appearance. The interconnects can remain in gray, the meshes. So this concludes our geometry in the Creo section. We'll save it and we can export it from here. We can export the assembly as save a copy, and save it not as an assembly file but as a step or IGES. I would prefer IGES for export to Ansys. Now this has been created and we have the assembly file also. So now let's go back to the workbench and we will add another geometry module. It's better to add directly a mesh module, and double click it to get another row. So and you'll have another mesh. This will be again direct import Creo model, and the Creo model using IGS. So let's open the space claim. You see we have got a number of files for every part, and then the main assembly file. We have an assembly file. We did made an .asm are the assembly files, and the IGS file. Now in the design we can directly open it like we did previously. So we can directly open, the first is to directly open the assembly file, so we can have all supported files and make sure that which one is the correct one. So Creo actually saves all the steps that we save, so we should go in and actually delete all the previous versions. So you could go to manage file and delete all versions. Yes, so now there will be only one file. So let's go back to space claim, and now if we cancel and open again, the assembly, there's just one assembly, so we can open it. Yeah, so now we got all the parts properly like we have designed, and all the parts are beautifully lined. This time we just need to first measure it, that to ensure we are getting the correct length important. So this is 0.5 mm, this is again 0.5 mm for the mesh, and this is 1 mm, so everything is okay. This should be 19 mm. Yes, all that we need to do is to just share the topologies, and you see now the coincidence tolerance is 0.2 mm. That's not good. What we need is 1 micron. So hit enter, and now we have got 5 faces. Now let's share again. So model 2, only 5 faces. Either we need to select all the surfaces properly. That's a tedious job, and so now this is properly. So we need to uncheck this preserve instances and now check that we have got all the faces properly highlighted. So even the minimum most is the AFL, that will be the most important in having them and making the shared topology, and just clicked OK, and now all the topologies are shared properly. So now we can close it, and this is this concludes the session. That this concludes importing the geometry from the Creo Parametric directly, but now we'll also go to look if we import from the IGS format. Open the space claim again, and directly open the file that we used previously, model 2, and we need to find the IGS. Now you see that IGS actually imported all the surfaces, exported all the surfaces, so we don't have a solid model. We can add the solid model if we selected the proper options while we exported from IGS. So we can have it like save as, save a copy, and when we go to the IGS options, all parts, as is. So we will be needing that, not quilts, as is, as solid entities, and OK. Okay, well, let's just overwrite it. We don't need the previous one already filled. So with this geometry in the space claim, go to the space claim and delete it. In the model 2 we have okay, we will try to export it again. So from the Creo Parametric we will go to export, save as, save a copy, and in IGS format, but we want to select the options in advanced as is, and because the Ansys will take only B-spline, it gives the error that there were no B-spline, so we check this curve, export all curves as B-spline, and we want to export as is. Okay, I think that should work. Okay, and okay. So the IGS now, it has been created again, and we can go to the workbench now and try to load the geometry again. So let's clear generated data. and open this one space claim. Right now there's no data in it, so we will open it, and again all supported files, and we should select the IGS format now. Now we get our model from Creo Parametric, but it named itself all the components, not the part names that we gave, but we got it all as a solid geometry now. And you see full cell model to assembly, and now again we should check that whether we got the same dimensions that we are looking for, that this desired, and it is 1 mm, that is correct. This is 0.007. Yeah, everything is okay now. Now again, if you want to make it so we can share it, because if you want all these components to go from meshing, then we need to share it. Sorry, share, not unshare, share. And now you see that there are 134 faces, so we'll give it 0.001, and one face is increased, and okay. We see that everything is okay. So this concludes the session for advanced model geometries. We modeled in 3 different environments. The first was the space claim itself, and the next we modeled in AutoCAD, and then in Creo Parametric. So, so now we have got all the models, the same model in fact, built in different environments and export formats. So next we will discuss about meshing.